Hello Level 3s, you'll be happy to know I have a new microphone, so hopefully the sound is better for you. So we're going to look at reviewing concepts of impulse and then impulse in 2 dimensions. Previously we looked at momentum and work and energy in class, where we realized that energy is the ability or capacity to do work, and energy and work are synonymous. We also realized that in order for work to be done, that an object must be displaced in the direction in which the force is applied. Momentum, on the other hand, is defined as mass in motion, and momentum is mass times velocity in the equation. You've worked through activity 7a, questions 1 to 3, hopefully, and now we can continue on. So, change in momentum is where we're going to start off. An unbalanced force acting on an object causes a change in velocity, thus also changing the momentum in an object or of an object. So it's the final momentum minus the initial momentum gives us the change in momentum. In symbolic form, delta P equals P subscript F minus P subscript I. You also might remember that it equals F delta T. So just remember that if the velocity of an object changes, then the object must have accelerated, and in other words, it must have been acted upon by an unbalanced force. So there must be a change in momentum as well. Okay, and this change in momentum is called the impulse of the force. So an object experiences a force for a specific amount of time, and that's where we've seen this equation before in level 2, where F times delta T equals m delta V. So in other words, the change in momentum equals the impulse. So for example, on the left we have a diagram, case A, where the initial velocity is 10 meters per second and the final velocity is 5 meters per second in the opposite direction. And in B, you've got 30 going to 28, so going right and then left. Question is, in which case is the greatest velocity change? You might want to pause and have a think about that. So definitely in B, the velocity changes from 30 to negative 28 meters per second, which is a change of 58 meters per second, which is bigger than from 10 to negative 5, which is a change of negative 15 meters per second. In which case is the acceleration the greatest? So again, you may want to pause and have a think about that. It is also in case B, so the acceleration depends on the change in velocity, which is biggest on the right hand side in case B. If you look at a diagram, or rather a graphical representation of this, it might make a bit more sense. So in case A, you've got 5 and then negative 3, and in case B, so different 2 cases here. Sorry, you've got maybe 3 meters per second going to negative 1. So you can see the differences here. Which case is the greatest momentum change? Okay, again, you might want to pause. Same question, just about momentum this time. And again, it is B. Momentum change depends on velocity change, which is greatest. And so therefore, in which case is the greatest impulse? Again, that would be B, because the impulse equals the change momentum, and the momentum change is the greatest in B. Again. Now if we look at impulse in 2 dimensions, if you have an elastic collision And for example, a ball striking another stationary ball, so this might be a game of snooker or pool, and you have the stationary ball of the same mass exiting at 30 degrees. In which direction will the other ball, so number 2, be moving? So again, pause and have a think. Diagram will give you some clues. And the answer is 60 degrees, because when you've got a two-dimensional collision of identical masses where one is at rest, then they will move at 90 degrees with respect to each other in the final state. And there's a link to a mathematical solution in the slides if you want to have a look at that. So just to again represent this graphically, if the force is large, right, over a small period of time, then the impulse is going to be large. So force times time, change in time. Yet if the force is small over a long period of time, then the impulse is less and the damage is less, because the impulse is spread over time, or the impulse of the force is spread over time. So here, for example, is an egg with cotton wool. You can see how the cotton wool will absorb some of the shock, as it were, and here's the egg falling from a height with no cotton wool to cushion the landing, and so you've got a large force. This should be F over here, larger force, and so obviously in a shorter time, which means the egg will crack. So lots of examples that we can think of, but here's one: the use of airbags in a car, which minimizes the effect of the force on a person that's involved in a collision. So how they do this is they increase the time required to stop the momentum of the driver or the passenger, because obviously as a person continues to move forward but the car has slowed down or stopped, then that will cause a person to hit the steering wheel or the windshield with a large force. So what happens is the airbag is depleted, and that causes the impact to be extended over a period of time, and then the duration of the impact will increase. So that will cause less damage. Obviously there are exceptions to that. As an example, number 1, a small rocket motor is fired and given a force time graph as shown above. What impulse is produced in the rocket? So if you'd like to pause here and just try these quickly on your own. The rocket is part of a satellite of mass 20 kilograms. What momentum change has the satellite got, and what change in speed does the satellite have? So try and think about how you would solve those before you look at the answers. So for the first one, the impulse is 5 times 2 only, because it's between 1 and 3 seconds. The change in momentum is